This video is a reminder of how to calculate the displacement and distance using integrals with a trig function as an example. So in your formula book, if you were using it for your exam, you would have this formula for the total distance traveled from T1 to T2 is this. Okay, remember displacement would be the same integral without the absolute value symbols. And example 2 says a particle moves in a straight line so we've got t greater than 0 and an acceleration function given to us. So part A says find the particle's acceleration at times t equals 0 and t equals pi over 2. So for that, all we need to do is substitute in our values for t and evaluate them. Be careful with 0 and trig functions. You want to make sure that substituting in 0 actually does give you 0, which it does in this case. Our next one, pi over 2. So we've got 3 times pi over 2 minus sine of pi over 2, which gives us 3 pi over 2 minus 1 centimeters per second squared. And we're just going to leave it in our exact number format. So 3 times 3.1, etc. would be about 9. Divide by 2, it's about 4.5. Minus 1 would be about 3.5 centimeters per second squared. Part B says if the initial velocity of the particle is 3 centimeters per second, find its velocity function. So here, this should be giving you the clue that you need to integrate because you're given the acceleration function. And we're going to use an indefinite integral and our initial conditions to find our velocity function. So we're going to integrate 3t minus sine t with respect to t. When we integrate that, we're going to get 3 over 2 t squared plus cos t plus c, our constant of integration. And we know that at 0, our initial velocity is 3. So we can use that fact to substitute and solve for c. So here's a good example. We've substituted in 0. Our first term is 0, but cos 0 is not equal to 0. So just always be careful when you're dealing with trig functions. That gives us our constant of integration, which is 2. So therefore, our velocity function for the particle would be 3 over 2 t squared plus cos t plus 2. The last part of this question is asking us to find the integral from 0 to pi over 2 of v at t dt and then interpret the result with regard to the particle's motion. So right now, maybe you can already do this and you're already thinking distance, displacement, I'm integrating again, I'm going up another level. And that is what our integral is going to give us. It will give us the particle's displacement in the first pi over 2 seconds. So let's figure out what that is. We need our expression for the velocity from part B. And we're going to integrate it. So 3 over 2 t squared plus cos t plus 2. And we'll integrate each part. So let's see, we're going to have 1/2 t cubed plus sine t plus 2t. And then we've got our 2 limits of integration. Then the first thing that we're going to do is substitute in our top value. Into all those spots. And then we're going to substitute in our lower bound here. And again, with trig functions, I'm writing it down so that you can see it, but it's important to make sure that when you're substituting in a 0, it actually does give you 0. In this case, things are good. That whole lower bound, when evaluated, does give us 0, so we're just left with calculating our first bound. So we've got pi cubed over 16 plus 1 plus pi. Okay, and this would be our displacement in the first pi over 2 seconds. There are some more examples for you to practice with 14H. Good luck.